Couple of things. On the quiz, you'll notice I regraded the quiz. There was a typo on the last question that a number of you had a question with a typo in it. And I went through and I just out of curiosity, I checked the ones that had a question that didn't have a typo. And interestingly enough, I want to say that those who didn't have the typo honestly didn't do all that much better than the ones who did have the typo. Most of you still got that question wrong. I think out of 10, 20, out of 30 students, I had 4 correct answers, which says to me that you guys didn't really understand how to work through the thought process for that question. So I wanted to go over that so that because it's important that you understand, that you really sort of think this through. So the question was, if you had carried out an experiment in a calorimeter with 3 different substances, each of which was heated, you had a block of the substance, it was heated to a consistent temperature, it was 100.4 degrees. And individually, you add those blocks to the same volume of water at the same starting temperature. And you were given a relationship between the heat capacities for those substances. So it was substance X, Y, and Z. And depending upon your question, it might have said, we'll just deal with the one that had the typo. The heat capacity for X is greater than the heat capacity for Y is greater than the heat capacity for Z. So they have those relative heat capacities. The question is, which of those systems would have the higher change in temperature? So I want you to think about the fact that, or what you need to think about is the fact that heat capacity is a measure of how a substance responds to being heated. In other words, it's a measure of how much heat has to be added to that substance to raise its temperature by 1 degree Celsius. If it has a higher heat capacity, it absorbs more energy to raise the temperature to raise its temperature. That means it has more heat available to give up to the water. So the higher the heat capacity, the more heat that substance contains, even though they all are at the same starting temperature of 100.4 degrees. When they're put in the water, the one with the highest heat capacity is going to release the most heat and cause the greatest temperature change. So if the heat capacities are X is greater than Y is greater than Z, then the final temperatures are going to be greater for X is greater than Y is greater than Z. Does everybody follow that? You need to think about what it means for something to have a high heat capacity versus what it means for it to have a low heat capacity. And so what I did was I just made the question worth 0 points. So if you got it right, and very few of you did, 4 of you got it right, you got extra credit on that quiz. If you got it wrong, you didn't lose anything on that question. It was essentially out of 0. So that's what I did for that. Yes.
Just to confirm, so if you have a high heat capacity, it takes more energy to raise the temperature up?
That's correct.
Okay, thanks.
As I said before, it's really important that water has a very high heat capacity because it takes a lot of energy to change its temperature. You can see that in a number of ways. And we talked about this, I think I talked about this yesterday with a number of you, or maybe I think it was yesterday. What that means for organisms that live in water, all organisms have a very narrow range in which they can survive. It's one of the reasons why doctors get very concerned if your temperature rises above 104 degrees Celsius. If your temperature rises too high, your proteins will denature, your cellular processes stop, and that means death. Okay. Before death, you'll probably suffer seizures and other not very pleasant things, but ultimately, if your temperature goes too high, you will die. And that's true for all organisms. They have a very narrow range at which they can survive. So for organisms that live in water, they need to have a consistent environment. Many of them migrate to stay within the temperature that's comfortable for them to stay, so that they're living in an environment that's the right temperature. It's one of the reasons why warming of the oceans is so bad. It's changing environments for some of these organisms. But water has a high heat capacity, so it doesn't respond very quickly to being heated. It heats up slowly, it cools down slowly. Okay? Because it has a high heat capacity, it can contain more energy. It absorbs more energy per degree temperature rise than something that has a lower heat capacity. Okay, so hopefully you understand a little bit more about heat capacity now. One other thing that I wanted to do, I told you all I would show you an example of an equation, Hess's law equation that involved more than two equations. So I have, focus that. I have a couple here. This one is calculate delta H for the reaction. This is methane plus chlorine gas converted to carbon tetrachloride plus HCl. I will point out to you that the states are important because some of these will have different states. Water sometimes can be listed as a gas or as a liquid. It matters because the enthalpy is different. So we're going to use these three equations. And I told you that what I tend to do is I tend to look at what the products are and start with that. You don't have to, but that's one of the things that I do. Or I start with an obvious reactant. So, for example, when I look at this first equation, I see methane. This is the only equation that has methane in it. Methane is a product. I need it as a reactant. That means I'm going to need to reverse this equation. So I'm going to have to write this. And for doing this for speed, I will not include the states when I write this, but I just need to make note of the states in the equations. So I'm going to reverse this and say methane goes to carbon plus 2 hydrogen molecules. That's just writing this equation in reverse, which means I have to reverse the delta H. The delta H now is going to be plus 74.6 kilojoules. Okay, so that takes care of that particular reactant. Now I'm going to look for the product that I want, which is carbon tetrachloride. And that's here in this reaction. And it is exactly as written. So I'm going to use it as written as is and say that carbon plus 2 chlorine goes to carbon tetrachloride. And the delta H there is minus 95.7 kilojoules. Now I have I've accounted for this reactant and I've accounted for this product. I have not accounted for the hydrochloric acid, which is a product. I need 4 of them. This equation gives me 2. So I'm going to write this third equation, but I'm going to multiply it by 2. So 2H2 plus...
Professor, wouldn't you have to do that to the middle equation too? Because you need technically 8 chlorines.
No, because I'm going to get 4 chlorines, 4 Cl2s over here. Trust me, just follow me with it. Okay, because notice I have chlorine as a reactant here, and I'm going to have chlorine as a reactant here. That's going to give me my 8 chlorines. So 2H2 plus 2Cl2, this goes to, let's multiply that by 2, 4HCl. And since I multiplied this reaction by 2, I have to multiply this by 2. It is in the correct orientation, but I have to say 2 times minus 92.3 kilojoules. And now I'm going to add this whole thing up. And when I do that, I get methane, CH4. Notice that carbon is going to cancel. My 2 hydrogens are going to cancel. I now have 2 plus 2 or 4 Cl2s. And that goes to CCl4 plus 4 HCl. And if I check, if I write in the states, that matches the original equation. And when I add all of this up, I end up with a minus 20, let's see, I did it before, 205.7 kilojoules, a negative 205.7 kilojoules. Does everybody follow that? I have another one here. am willing to challenge you with it to see if you can do it rather than, whoops, let me get that up a little higher so you can see it. Can you do this one? Delta H for the reaction, 3 carbons plus 4 hydrogen molecules. This is a delta H of formation because it's forming 1 mole of propane. So 3 carbons plus 4 hydrogens forming 1 mole of propane. And you need to use these 3 equations to do it. And those are the associated delta H's. Figure out how you're going to do that to end up with that reaction. I'm going to let you guys do it. Once you've done it and you've calculated the delta H, write it in nice big numbers and hold it up to your camera and let me see. That's close. Yep, that's good. I would have rounded that, but yes, I would have rounded that to the ones place, Rowan, and ask yourself why that's the case.
Professor,
Yes.
is this right?
No. Sorry.
I would have did it to ones because of addition, significant
Yes.
figure.
Yes, it's addition significant digits. This first one only goes to the ones place. So when you're doing addition, you can add them using these decimals, but appropriately. But once you've added them, you have to round them to the ones place because of that one.
Professor?
No.
Okay, Professor.
That's correct. Yay!
Yay!
Yes, Flavia, that's correct. Except you have to round it to the ones place.
Wait, Professor, why would you round it? Which
It's the addition and subtraction rule, and the addition and subtraction rule says that you can only go to the as far as the number with the least number of decimal places. These two both have a one decimal place, so they are accurate to the tenths place.
Yeah.
But this first number is only accurate to the ones place.
Oh, okay. Gotcha.
So when you add it, you that's going to limit you.
All right. Thank you.
Well, everybody else is continuing to work on this. I am going to make a blanket statement. I am shocked and dismayed by how many of you are still not paying attention to significant digits. Arthur, are you showing me your number? I can't see it. Say something, Arthur, and just say something and your window will pop open as the speaker.
Okay.
And then I can see it. It's out of focus, but I don't think it's quite right. I think it's wrong. Say something again,
We have
because it's on speaker view, and if you say something, it'll pop up.
Okay.
Okay, it is off. It is wrong. Your number is wrong. So you have to rethink about it. Most of you are throwing away. Rowan, you're telling everyone what it is.
I thought we were moving on, so I wanted
we
to.
are going to. Well, it is 105. It is a negative 105. So if you did not get that answer, go back and look at what you did. In order to solve that, you have to manipulate every one of those equations in some way. If you
I needed like 10 seconds. That was it. I just 10 seconds. I was so close.
Okay. Anyway, I'm shocked and dismayed at how many of you still are not paying attention to significant digits. Many of you are literally throwing away credit on your labs. And when you do your workload uploads, 1 point is always for significant digits, and I'm taking away a point for significant digits on over and over again. And it was really very distressing to me at how many of you lost credit on the last couple of labs. On the Boyle's Law Lab, it is perfectly okay for you to carry extra digits in your calculations. It will never, ever make that big a difference if you carry 12 digits when you only have 3 that are significant. Carry 4 in your calculations. That's fine. But when you list your the values for the pressure for all of your books, some people were giving me 7, 8 digits. None of those beyond the third one are significant. I will allow plus or minus 1, but I won't accept that many. So you're throwing away credit. Significant digits isn't an exercise that we do at the beginning of the year just for fun. It is meant to point out to you that the accuracy of your data or the precision of your data only goes so far. It only goes as far as the precision of your measuring instrument. And if you can only measure the mass of something to 3 digits, you can't report the force in 9. You just can't. So many of you are losing credit because of that. Okay. So I suspect most of you would like to know a little bit about the final. Am I right?
Yes.
Okay. We still have not, it's still not finished, but I will tell you this much. I will tell you, it will come in 3 parts. The first part will require no work upload. They will be drop downs, fill in the blanks, multiple choice, formula questions. Any question that some of the questions will have numerical answers, but they're not answers that you will have to support with work. And so they will be in the first part. That will cover all of the chapters that we've done so far. So you might be required to calculate numbers of moles or numbers of molecules. You might be asked to do root mean square speed, calculate a molar mass using the root mean square speed equation, or calculate the root mean square speed of something where you know the molar masses of them compared to another substance. So using the root mean square speed. Mole fraction, make sure you know how to calculate the mole fraction of something. Make sure that you know how to use Dalton's law. If you have a mixture of gases, or you have a gas collected over water, make sure you know how to calculate, separate out the pressure of one component of the gases. Quantum numbers, that could be in there as well, identifying quantum numbers. Molecular shapes, anything having to do with molecular shapes or orbital diagrams, or periodic properties, that could be in that section. Sigma bonds, pi bonds, those kinds of questions, counting how many sigma bonds or pi bonds there are, could be in that. Make sure that you know the difference, because some of you don't. Some of you got these confused on a quiz recently. Make sure you know the difference between formal charge and oxidation state, because some of you confused those two. So make sure you know the difference between formal charge and oxidation state and when each of those is used. But those things can be in there.
I remember we on the last test, or not the last test, but the test where redox would have been, it had like no questions on oxidation state. Can we be expecting that to not really pop up at all in the final again?
Oxidation states can be there. They will not, they'll be on, you'll be given something like, I don't know, XO4, for example. Give me the oxidation state of X. Okay, so they're not going to be compounds. It won't be like SO4 2- or something like that. It's going to be something. It's going to be something with an X in it, because there are applications online where you can type in any compound and get the oxidation states. And so I want to know that you know how to calculate the oxidation states, not that you know how to look one up. So if I give you compounds with X or Q or something like that, you can't look those up. They will be made up compounds. But yes, you can expect those in there. You could expect to see some equations where you're given two reactants and asked to predict the products, either a double displacement, a precipitation reaction, or an acid-base reaction. So make sure you can look at those reactants and know how to predict products for those. You might be asked for, these will be essay style questions, but don't require work. You might be asked a question for a net ionic equation, could be in there. You could be given equations and asked to identify what type of equation are they? Are they a single displacement? Are they an oxidation reduction? Are they combustion? Is it an acid-base equation? Things like that. So you might, those might be given to you, and that would be just a fill in the blank or a drop down or something like that. You're likely to see a Hess's law problem. If you're likely to see a Hess's law problem, it's likely to be in that part of the exam, because I really don't need to see your work. You either get it right or you get it wrong. So you either manipulate the equations the correct way or you don't. And so you either get it right or you get it wrong. Identifying in an equation what is being oxidized, what is being reduced. So you need to know what the definition of oxidized is and what the definition of reduced is. So being able to recognize what's being oxidized, what's being reduced. Simple density conversions could be there. I don't need to see the work on those. Most of these equations, as I said, are either drop downs, fill in the blanks, some formula questions, essay questions, multiple choice, things like that. Most of them are around 2 points. Some of them might be slightly more than that. Some of them might be 4 points, but they're not going to be 3 or 4 points, but they're not going to be, none of them will be worth a ton of points unless there's multiple parts. I will say that of the 3 parts, they will probably be roughly the same time allotment for each of them. Okay, so they'll be roughly the same time allotment. So that's one part. Part 2 will be a work upload. I am going to have you do the work upload separately, but there will be a work upload required for part 2. I think that most people have been happier when I do the work upload as separate from the actual test, because you all seem to panic that you're not going to get your work done and get it uploaded in time. So there will be a 4th part that involves just the work upload. So there are 2 parts that are going to require work upload. The first is part 2. It will be mathematical problems that technically will be mostly chapters 6 and 7. It could be anything from chapters 1 to chapter 7, but mostly it'll be chapters 6 and 7 because that's where the math was in the first part. Percent composition, calculating the percent composition of something. Using percents, using given percents to calculate the empirical formula or the molecular formula. And remember that using the percent gets you to the empirical formula. You have to compare that to the molecular mass, the molar mass, to determine the molecular formula. So using percents to get to molecular formula, being able to calculate the molarity of a substance using the mass, for example, of a compound. Can you calculate the number, using a given mass and a given volume, can you calculate molarity? You have to turn the mass into moles and then turn that into molarity. Percent yield from a reaction. If this is, you might be required to calculate the theoretical yield, but you would be given the actual yield and then asked to determine the percent yield. Calculating theoretical yield using mass and volume of 2 aqueous substances in a precipitation reaction. That means you're going to have to calculate the limiting reactant or figure out what you're going to have to calculate the moles of each and figure out what the limiting reactant is to calculate the theoretical yield. Doing a limiting reactant problem might be part of that. We're going to try to do the hydrate problem again, like the ones you did in lab, only this time, hopefully they will be set up correctly and I won't have to discard them as I did the last time, because whoever wrote them the last time wrote them wrong. But it'll be just like what you did in lab. So if you've done the lab, you should be able to do that.
What were written wrong?
The hydrate problems you were asked, when you were asked to determine the moles of water in a hydrate,
Yes.
You have to calculate the moles of the salt using the dry compound after it's been heated. So you use the mass after it's been heated. The difference in the mass between before heating and after heating gives you the mass of water. That gives you the moles of the water. And whoever wrote that question before, and I don't know who did, but whoever set it up must have done it in a hurry, because when they calculated moles, they calculated the moles from the hydrated sample, from the hydrated mass. And so all of them were wrong. And I ended up having to discard that question from that test. So we'll try that again. But
Also, I remember the wording of that question was weird. Like, I could have done a hydrate problem with ease, but the way it was worded, I didn't even recognize the problem.
okay, I'll check how it was worded to see. Okay, so that's part 2. All right, so that's a work upload part. Part 3 is also a work upload part. That is the part that's going to be concentrated entirely on 8 and 9. For 8, you can have a combined gas law problem. You could have a PV equals nRT problem. You could have a stoichiometry problem that involves PV equals nRT. So give an equation if one of the products is gas, working back from the moles of gas that are produced or whatever. So stoichiometry and PV equals nRT. You could have a problem where you have a gas collected over water that involves separating out the mass of the vapor pressure of water before you do PV equals nRT. You could have a problem that asks you to calculate either the density of a gas or calculate the molar mass of a gas. Remember, that's just a manipulation of PV equals nRT that uses the relationship of mass divided by molar mass equals moles, and mass over volume equals density. So it's just a manipulation of PV equals nRT. So all of those, except for the first one, that's like 5 different examples, and all except for the first one, all involve PV equals nRT in some way. You could have an effusion rate problem from molar mass, or molar mass from effusion rate. Or you could have a root mean square speed problem. So make sure that you have those. By the way, I don't mind if you have a piece of paper with all these equations written down. I'm not controlling what you're using as your support material. Even if I were giving you a test in class, even if I were giving you a test in person, you would absolutely have a periodic table, and I would absolutely allow you to have a 3x5 card with all pertinent equations on it so that you don't have to constantly remember them. So if you want to take a 3x5 card and write down all the equations for these chapters, by all means do it. I don't have a problem with that. So those are all problems that you could have from chapter 8. From chapter 8. From chapter 9, you could have Q equals mass times heat capacity times delta T. So you could be asked to calculate heat flow using a calorimeter. You could be given a coffee cup calorimeter problem, like a substance dropped into water, a block of a metal dropped into water, or a chemical reaction like you did in lab. What happens when you mix an acid and a base and the temperature goes up? Can you measure the delta H of that reaction from the rise in temperature? So coffee cup calorimeter problem. You could be given a problem that involves a bomb calorimeter. You could also be given a problem that involves calculating delta H using the heats of formation. Remember, I told you I have to give you a table of the appropriate heats of formation. I did want to show you, and let me open this up. I will show it to you. I will show you this. Switch my camera for a minute. Okay. This is from a text. This is from a textbook. This is just one page. And you can see that this goes on. That's just one side. That's 2 pages. So that's I guess it begins on the page before that. But you can see that you can get, I don't think it shows you there. This is the delta H of formation. And so you can look at and see the bromine liquid, it's 0 because that's its standard state. But bromine as a gas, that's the delta H of vaporization. That's the amount of heat that you have to put in to vaporize it. So you can go through this and you can find all kinds of compounds. If you find water, you'll see water as a vapor, you'll see water as a gas. Obviously, that's, if you have access to a text, you can do that. You could do it from the text. It's going to be a lot easier for me to just simply give you the ones that you need to know if I ask you to do that type of problem. So you could have calculating delta H using the heats of formation. Remember, that's just the summation formula. Sum of the number of moles of each product times the delta H of formation of that product minus the sum of the number of moles of each reactant times the delta H of formation for that reactant. Now, one of those will be, if I give you one of those, either that or the bomb calorimeter or something like that, it will be an extra credit problem. Okay, so you will get one extra credit problem, and it will probably come from Chapter 9. Okay, because although we did spend quite a bit of time on Chapter 9, I recognize it's the last thing we've done, and it's a little stressful at the end of the semester. So you will get one extra credit problem. It will probably be worth about 8 points, which isn't quite 10% of your test, but and then and then I will give you the fourth part, which is the work upload. Okay. So that should give you an idea of the kinds of questions you could be asked. And I'm not giving you an exact number of questions at this point. I'm giving you the material that I'm going to be covering and where you'll find it. Any questions on that?
So how long is a typical part will take?
The test is meant to be about 2 hours. I think if I allow the time frame, because I'm likely to allow you about 45 to 50 minutes on each part. If I do that, that's actually longer than 2 hours. If I do that, it's not because I think it's going to take you 45 or 50 minutes. It's that I want to allow you 45 or 50 minutes so that if you're taking a little bit longer with one problem, you have a little bit of extra time to do it. Is that clear?
Yes.
I don't want to cut you off short. Okay. So if I give you 45 minutes for each, that's about a 2 hour and 15 minute exam. If you have the time and want to take 2 hours and 15 minutes, you have it because I've given it to you. If you are constrained by time with the 2 hours, or you don't need the full 45 minutes for each part or something like that, you certainly should be able to get it done. I think you'll get it done within 2 hours. I just don't want to cut you too short on the time I allow. So I'm probably going to allow you 45 to 50 minutes on each part, depending upon how many questions are in each part, so that you have plenty of time to do them.
Just going to ask how many questions it was going to be.
Don't know that yet. The sample test that we're working off of had, let me think. The sample test that we're working off of had 19 or 20 questions in part 1. That's the non-work upload. It had 8 questions plus an extra credit question in part 3. And it had 7 questions in part 2. That's probably a pretty good estimation of where it's going to end up.
Are there going to be questions on chapter 3, like on all those wavelength and?
No.
Nice.
No chapter 3 questions?
Not on wavelength, not like that, no.
Like not the math equations?
No, not calculating wavelength or anything like that. We tested on that. It's the final exam, because it's cumulative, is really meant to be more of a big picture kind of thing. Obviously, we're testing on chapter 8 and 9. It's our first test on chapter 8 and 9. That's why we're emphasizing it more. But when we look back on the rest of the material, what's far more important is, can you bring this all together? Can you pick up and connect important ideas? Important ideas are, because we're talking about chemistry, and chemistry is talking about molecules and compounds rearranging and forming new molecules and compounds. Obviously, chemical reactions are important. Being able to identify reaction type, being able to predict products, being able to understand what substance is being oxidized, what substance is being reduced, understanding periodic properties, how atoms are related to each other as far as ionization energy or atomic size based on where they are on the periodic table, quantum numbers, because arrangements of electrons in atoms is critical to how they react. So we're really looking at big picture items, and calculating the wavelength of light is not a big picture item for chemistry. I mean, it helps you get to some of that other material, but it's not a big picture item.
I just have a question about part 1.
Yeah.
You said it's no math, but then you still require to do
it's simple math. It's simple. Yes, there's simple math, but you don't have to provide justification for your math. So if there's a Hess's law problem there, you have to give me your answer. Your answer is either right or wrong. It's not going to help me. I can't give you, if you've made a mistake, if you needed to multiply an equation by 2 and you didn't do it, I can't give you partial credit for that. So it's your answer is either right or wrong, but they're going to be simple ones. They're not going to be real complex. I could find, trust me, I could find some really complicated ones that require 4 or 5 steps, but I won't do that. They'll be much simpler than that.
And mostly going to be like multiple choice and then drop down questions.
It'll be multiple choice, multiple answers, fill in the blank, drop down. If a formula question, like if you're asked to calculate a simple density, then it will be a formula question. So you'll enter a numerical answer. There will be a couple that are essay type questions. If they're essay type, so if they are essay type questions, those aren't automatically graded. So your grade at the end when you submit that won't be final until I've graded it. As you know, it's never final anyway. I always go through them.
Okay, thank you.
Anything else?
Would there be questions on parts per million, per billion, or also balancing redox reactions?
Probably not either. Just predicting products. Any other questions? Yes, no?
Can you show the last problem you did?
That was 2 at once. What was that?
Can you show the last problem you did?
The last problem I did? You mean the
Yes.
Hess law.
Hess's
Right.
law, the one that I did, or the ones that you guys were supposed to do?
I just want to see them so I can redo them, like both of them.
Okay. So this is the one that I did. And as I said, I usually, the way I do it is I look for the species that I want. I need methane as a reactant, so I know I have to flip this. I need this as a product, so that's fine in that order. This is in my other product, but I needed 4 of them, and this only gives me 2, so that tells me I have to multiply it by 2. The one that I gave you guys, this one, let me just to do this one, you had to manipulate each of them. This is a reactant. Your propane is a reactant, and you want it as a product, so you're going to have to reverse this one, which is just going to, and leave it as is. You don't have to multiply it by anything, but you have to reverse it, which means you change the sign for this. You then need, you need 3 carbons, so you're going to have to multiply this one by 3. And you need, let's see, that's going to give you 3 oxygens. You are also going to need 4 hydrogens, so you're going to have to multiply this one by 2 to get your 4 hydrogens. Those are your 3 carbons and 4 hydrogens as your reactants. And then you've got 5 oxygen, which will cancel with this when it's on the other side. One thing I will tell you guys, it's very helpful if you keep your arrows lined up when you write your equations on these. It's always very, it's because it helps you see when you're writing them down here, if like I did up here, I do try to keep my arrows pretty much lined up so that I can cancel appropriately. I do have one other that I can show you. Let's see. Here's another one. You could probably write this one down and challenge yourself with this one. You need to calculate delta H for this reaction using these 3 equations.
So this type of question gonna be on part 1 and part 3, right?
It could be in part 1 or part 3.
Oh, okay.
Professor?
Yeah.
You have something in the discussions due for today. Are we doing that?
Oh, I forgot to open that up the other day. It's you can absolutely do that. There is a discussion there, and you can absolutely work on that. If you'd like me to break you out into breakout rooms, I'm more than happy to do that, and you can work together on it. It's on chapter 9 to give you a little bit of practice on that kind of a problem. The chapter 9 problems. I forgot to give that to you. I meant to give that to you Tuesday, and I forgot. I forgot to publish it.
All right, thank you. Also, for the start time with the final, it has to be started at that exact time.
Actually, I think I have set them all to open at 9 o'clock. Technically, the final starts at 9:30. But I think I set it to open at 9 o'clock. I will be available from 9 o'clock on. If you're taking the exam at a different time, those of you who have special accommodations for whatever reason, Aiden, I know that your situation is unique because of your concussion. You need to let me know when you're going to be taking it. So that I know that I can be available if you have questions. Otherwise, I will be available from 9 o'clock until noon on Thursday, which is your exam time. I believe that allows you guys, unless you have a lot of extra time or more than, I'll try to be available for the extra time people as well. But if you're going to have special accommodations, then you need to let me know when you're going to take it.
All right, thank you.
Okay. Because this is remote synchronous, you are expected to take your exam during that time. If you have extra time, that have to work out. But you otherwise, it's not like an online class where you can sign on and take it whenever you want. You are expected to take it between 9:30 and 11:30 on Thursday. I do have them set to open at 9 o'clock, and I will be available from 9 o'clock. You don't have to start taking it at 9 o'clock. You're not required to start taking it until 9:30. Okay, I'm going to let you guys go into breakout rooms and you can do your discussion. Practice it. See if you can do it.